Okay, so this is going to be the first episode of a creative session, and I wanted to make these videos somehow different than the regular tutorials that I upload. And in these, I'll be working on um, diverse projects, and I'll be looking at different types of tools and plugins in Grasshopper. So we'll be connecting a bunch of different information and working on cool things, I hope. So this one actually came out of a curiosity of mine when I was looking at weaverbird and lunchbox tools. And to give you kind of a breakdown about them, weaverbird gives you operations that kind of work with meshes, the most powerful of them being the subdivision tool. And lunchbox gives you paneling options that kind of work with surfaces. So there was one tool that I was really curious about. So when you, for instance, create a surface, let me delete these. So when you create a surface, so for instance, let's do this, a planar surface, and you want to load it. And so basically when we grab, let's say diamond panels. So when I connect the diamond panels, you can see that this kind of gives you a bunch of diamonds and triangles. But these are actually separate surfaces. So when I access them, I get, for instance, these are the quads or the diamonds, and the rest of the triangles are being output as triangles as well. Now the problem is when you actually make it, let's say we make a lofted circular shape. So I loft these two curves together, so I get a surface. Now the script executes the same way, but the problem is when I, for instance, bake the diamonds, you would see that, so let's move this around and switch to rendered mode. You will see that there's a gap, and that gap actually comes from the seam of the surface. So when you're actually creating an iso surface, let's say this is an isometric surface. So basically it's isomorphic. Well, isomorphic might be actually a better term to use for this because it's continuous. There is actually a seam that separates the start of the surface and the end of the surface. So the parametric information actually flows from this side to the other side, right? And we actually get these kind of quad openings, and they're actually there when you actually bake the triangle panels as well. They're actually there, but the problem is, let's say you want to do something with the quad, then there's no quad there because the information is broken because of the surface. And I wanted to look into this issue, and we cannot actually use this. If you want to have quad panels flowing along a circular surface, then you have to actually feed in how the quads are constructed to the surface. So that's kind of the formulation of the problem. And we're actually going to look at how to figure this out. So I'm going to start with a planar surface first, and let's load this back in. So let's look at some of the tools that we can actually do with the planar surface. So what I want to do is get the points on the surface, and to begin I want to have, let's say, a 10 by 10 point count of the U and V. Now the output is interesting. So when you actually look at the output, you can do that with the point list, and you can put, like, let's say 5 here. You can see that there are multiple lists, and the lists are going in this direction, right? And what I want to do is filter the data in such a way that I can actually build quads out of this. So what I want to do is, let's say there's going to be a quad here. I want to connect these points in this fashion, right? So the next one, so because I started with 1, I'm going to start at 3 here, and I'm going to go in this way, and so forth, right? And when I switch here, I'm going to start with 2, 3, 2 here, 1 here, and then close. So this is going to lead to some sort of patterned construction, right? So we want to first construct these rows and then switch to these quads. And the key problem would be, how do we actually build the quads on the left, right? So the quads on the left have their 3 points here, and the remaining point is going to come from the right side. So we have to actually work around with the point lists in this case. So I'm going to first look at the tree branches, because when you look at the output of the subdivision, it gives you branch data. So when I simplify this list, you can see that there are 11 branches containing 11 points. If you want to access any of these branches, you can actually, let's say, do this as 10, and I feed this in. So I can actually grab any of these point lists. So the first one is at the bottom. You can see, the first one is on top in this case. Actually, let me do this. Okay, so it starts from the top, goes to the bottom. I wonder if this is going to affect how I construct my surface. We can probably look at it from bottom up in this way so that the numbers are not too complicated. So yeah, it starts from the bottom, goes up. I think it has to do with how I constructed the surface. So let's go back, delete these, and let's do it like this. Set one surface. Sorry, let's do planar surface. Okay. Set one surface, and let's see, 9th row, 0 is always on top. No, that should be okay actually. I mean, we can start from 10 and go down, but essentially what I want to do is kind of flip this around. I want the 0 at the bottom so that we can actually visualize things a lot better. So 0 is at the bottom, and we move up. Yeah, that's actually a lot better. I mean, I did a quick switch there so that we can see the construction a lot easier. Now, now we have these, and what I first want to do is get, so as I said, the first quad, right? So let's disable the center. I want to start here and go in this fashion. So essentially, the next one is going to be on top of this. That means I want to get this row and this row and this row. So I want to get every even row in this list, and I'm going to do that using series. So my series is going to start at 0. Its step size is going to be 2, and the number of rows I need to get are going to be 0, 2, 4, 6, 8, and 10. So that's going to be, I think, 5. So let's feed in 5. We get up to 8. And when I feed this in, I get these. So that's actually correct. So you might actually want to assign some sort of mathematical relationship between these divisions as well. And that's something we can actually look into later. The next one is going to be getting these points. And that's going to be probably a simple call pattern. So I get the call pattern, and my call pattern is going to be a false true, I think. So we get these. So these are going to be the bottom of these quads, right? So these are pretty much done. And you can move this around. Let's push it here. I'm going to delete this one, and I'm going to make a copy of it and move on to these points now. So those are going to be at odd rows. They're going to increment in 2s as well, so that we get these. But the difference with these guys is going to be, we actually don't need the left ones, right? So we're going to actually shift the list. We're going to use shift list here, and these guys. So when we shift, let's see, it's also doing call pattern. So these are the branches. Then we get them to 5. Okay, why is it switching to those? Let's hide this one too. Okay, these are the rows. So when I do a call pattern, oh, the call pattern is wrong. So this is supposed to be reversed so that we get these points. And then I want to do a shift list, and I want to get rid of the last, the first. So my index is going to be between 1 and -1. And this is going to be -1, and the wrapping is going to be false. so that we don't wrap them around. So -1, let's see, -1, and this is 1. Yeah, this is what I want. So I'll basically copy these. So when I do it like that, yeah, the last one gets their point as well. So that's pretty much it for the right points. And then I can probably make another copy of this one, and this one could be -1, so we get the left ones as well. And now I have the top ones left, and the top ones, we can probably get a copy of this guy. And these are going to start at 2, and let's see, they're going to go up to here, and the pattern is going to be, let's see, it's going to be reversed again, I think. Nope, this is correct actually, so we don't need these. So this is the pattern, then we do a call pattern. Let's copy this one, hide this guy. Yeah, this is pretty much it. So you want to check that these points are identical. I mean, the point counts, so there are 25 here, 25 here, 25, and 25, and the data is somehow different, but that doesn't matter. Actually, we're going to just weave them together, and my weaving pattern is going to be a simple 0, 1, 2, 3. So we're going to grab one item from each of these lists, and you want to flatten these first so that we get rid of the grafted data, and then I'm going to graft these so that they could be put to individual lists. So this was the bottom point. Where are these guys? Let's see. These are the right ones, these are the left ones, I think. So we go to this, then this, and then this. So we should have 4 points each. And if I do a polyline, okay, I connected these wrong, I think. So we go from here, or we should go to top, and then we should go here. And then I want to make these closed. And so these shouldn't make us confused anymore. And I'm going to do boundary surfaces here so that we can see the surfaces that we have made. So these are the first quads that we have completed. And this is pretty much the code for it. I'm going to move this around a bit. Let's move it here. Now the first point I want to make is we want to be able to control the numeric count here actually. So when I increase this value, you see that this doesn't repeat, right? It's because we're only getting 5 points for 5 rows for each of these. And I want to first limit this to even numbers, and then let's put an evaluate here. And the evaluate is going to be x divided by 2, so that we can replace this 5 with these guys. Yeah, so now when I move it, you can see that it's populating correctly. Okay, then, so we don't need these numbers anymore. All right, so we can now, let's see what else. If I increase this one up to 20, yeah, that's gonna cause more issues. Actually, let's make it even as well. It just fixes it up when you make it even. So that's all good actually. And now that we have done those, let's do these. So I'm going to, let's see, we need to find these points now. And to find those points, so this row is going to be, let's go make a copy of these guys. Go down and let's look this up. So we want to work with these right now, and the pattern is going to be a call pattern. That's correct. We actually don't want 7 for these. I think we don't need this row. We want to actually stop there. So I'm just going to make a copy of this one. Put this guy in parentheses and then do -1 so that we get 1 less of that. Put it there. So we have, these are going to be the bottom of these quads, right? So this is going to be there, that's correct. And I'm going to do a shift list and get rid of the last item. of this one too. So let's see, that is correct. So the overlap is going to happen in these panels, right? So this guy and this guy is going to merge. So what I want to do is start from here, go there, and then go to the left of this guy. That's going to be where, that's going to be the trick. Now that this is done, then I want to go to this row. So let's make another copy of this. This time I want to start at 2. Let's see, switch to that row, that's correct. And this, let's see. This seems to be okay actually. I think this is okay the way it is. So we can just keep it. Do we need to actually shift anything? Let's see. If I disable this one, this is correct. Okay, this one is giving all the lines, all the points. This one, oh, is giving these. That's actually what we don't want. Let's reverse this one, and that's correct now. Okay, we don't need shift for this guy, so I can just use this one. Okay, then I want to switch to these rows. So another copy. Let's see. This one is going to start at row 3. Go up by 2, and then we're going to do a call pattern. Let's find the pattern. This is probably going to be reversed, and that's correct, but we want to get rid of this guy here. So another shift list with -1. And that's going to be my final points for the top. Now, for the last one, I'm actually going to make a copy of this guy, put it here. And these points, let's actually look at this one as a point list so that we make it correct. Okay. Oh, it's really hard to see, but let's see, 0, 1, 2, 3, 6. So what we want is 6 to be 0 and 0 to be 1, so that it belongs to the second group and this belongs to the first group. And to do that, I'm going to do a shift list. Let's actually make a copy of this guy. Make a shift list of -1. Let's take out the flatten. So 0 moved there, but we want the wrapping to be on. So 0 is here, 1 is there. So this is I think correct version. I'm going to delete this one. And let's bring this here. We're going to make another. Okay, these are flattened. Let's flatten this one too, and this one as well. This goes here. This goes here. This guy is here. Okay. All right. So this is actually correct. You're seeing this overlap, but that's because we want it to be wrapped around the surface, right? So that's, let's actually put it to test. When I loft this, all right, let's get these surfaces connected as well. Although we won't be able to get the boundary surfaces, the flat surfaces in this case. So let's just get the, let's actually turn these into network surfaces. Let's do a network surface. And one way to do network surface is just to explode these into segments, and then we can do a small call pattern here, and the pattern would be let's say false true, and this would be reversed. So these are going to be UNV, and those are going to be network surfaces. It's exactly another way of doing boundary surfaces, just when we switch to 3D, these surfaces wouldn't be flat, so they cannot be boundary surfaces. Okay, so I'm going to select this guy. Okay, now when I let's put these here. When I bake this, okay, now we switch to rendered mode. You can see now it's connected. So now I figured out, so this is where the seam was, right? And I have a quad panel there as well. It's because the first panel is connecting to the last one, right? So this is actually pretty good. Now in the next phase, let's actually turn these into something else. So let's make them a bit hollow. And one way of doing that would be, because we have surfaces now, I can probably let's flatten this list, and then we can evaluate the surface at an XYZ point. This is 0.5. Okay, so I want to get the midpoint, and I want to let's see. Oh, these are supposed to be reparameterized so that we get the actual midpoint. And I want to not actually work with the surface, probably. Can we do the wireframe? Boundary representation wireframe. Okay, and join curves. Well, this is going to be tricky. Actually, let's try to scale. If I get this, this is my center of scaling. Okay, and no, this is the center of scaling, and the factor is, let's say, 0.5. All right, it's actually not doing it right. Oh, it's because probably this is grafted and this is not. If I graft this one too, okay, now that works. And these two, I wonder if we can make something else out of it. So so these lines and these lines, can we actually loft these? One thing would be to turn them into flat surfaces, but the other one is actually turn them into quads, which is probably a lot better. So we can do a simple weave here and graph these guys. Take out the simplification, and these are the first curves, and I can flatten those out. And these are the second curves. I can flatten them out as well. And then we can make a loft and see what happens. Okay. Now let's bake this one. All right, that's looking actually pretty good. So now I have them as flat surfaces, but I actually want to make them as meshes. So one way of converting these to meshes, I mean, I wanted a smoother model, so we can actually make these a lot smoother. So one way of converting these to meshes is, let's see, if I do deconstruct brep, so we get the faces and the vertices, and I want to do a mesh quad. Okay, and construct mesh. The reason why I'm trying to get it into mesh is because I want to subdivide it. So these are the vertices, these are the faces, and when I bake this one, now this should be, now this is actually pretty good. So these are meshes now. And the last step would be actually kind of weaverbird tool, so we can weld these, join and weld. And you want to flatten this out so that that becomes a single mesh, and then you can do any type of subdivision you want. So let's try loop, for instance, and let's bake this guy. Okay, so that's actually what I wanted. So that's like a smoother model. The problem is the scaling. The scaling is right now just happening in place, whereas we can move the center of scaling inward or outward, and we can do that by getting the vector amplitude. Sorry, this is the wrong one. Vector amplitude. So get the normal. Let's see, minus 50 to 50. Would that work? Okay. And I want to move this point that we evaluated using this vector. So this is too much actually, this moved too much. When it's 0, it's on the surface. So 1 actually moves it inward. So let's look at when it's moved inward a little bit. So let's say we keep it at 2, and those are going to be the new centers of scaling. There's a bunch of stuff we are looking at actually. Let's hide these as well. All right, now if I increase this, you can see it's actually bulging a lot nicely, and that's something we want. We can also extrude it outward. That's also something we can do. I'm gonna keep it inward a bit, let's say 10. So when I bake this now, this is the model I'm getting, right? So it's like a subdivision model. And let's actually turn this into something else. We are going to, let's delete this one too. So what if we have a different type of profile? So because this was a lofted surface, we can actually start with a circle. Circle at the origin. Let's say radius is 50. And I'm going to have a series of these. Let's say the gap between them is going to be 10. And I want 20 of these guys. And let's construct a point. This is their Z. Okay. And let's actually decrease these guys a bit so that I get to a similar shape like the one we had. That's okay. Now let's throw in some graph mappers. So for instance, we could do like a Bezier for scaling. Right, so we could do scale. And I want to scale these geometries at these locations. And we need a range here, and I need one less value than these guys. Okay, so this goes here. All right, so these were the initial ones. This is the last one, and I want a shape, let's say like that. Okay, and the other thing is maybe rotation. So what if we twist this actually? So I can make another copy and multiply it first with kind of an angle value. Let's call that 180. And let's switch this to radians. And I want to rotate an object in a plane. I want to rotate these circles using this angle. And what happens when we loft? Let's see. So I want to get this seam. So now our seam is not flat. It's going to be dynamic, because we are twisting the shape. So let's make it a little bit more interesting. So maybe our shape is like that. Okay. And let's see what happens when I connect this one here. Okay, wow. So it probably switched because this was a lofted surface, and we can decrease the extrusion value inward. Let's say -8. Okay, so this is our shape now. So if I bake this one, that's actually pretty good. So that's the shape I get. I don't know what what this is going to be yet, but I mean, it looks cool. So we can probably use it for a bunch of things later. Okay, so this is working as well. Let's push it outward as well. Let's see what that does to the shape. Make this one. That's nice as well. So, I mean, the subdivision is kind of smoothing the shape. It's not making it as smooth as we would like. For that one, you might have to use like additional tools, maybe Kangaroo. But it's giving me the result I actually wanted. So some sort of physical deformity, right? Some twists, and basically we can control the lofted shape. We can control how much twist we want, right? And then you can actually make this like really interesting. Let's keep it like that. So let's see. Let's generate a bunch more. You actually don't want to touch this part which does the quads, and we can probably also change the radii too. So let's change the radii, and maybe like that. Looks like a dress now. Okay. So because the shape is continuous, we can make any type of graph manipulation on it, and we can get anything we want, right? So this can be used in a bunch of different ways. I'm going to probably make a few more variations, but this is kind of it, I think, for this session. So I hope you liked it. I'm thinking of making a video like this every week, where we can actually do some cool products or cool scripts and connect a bunch of stuff. I'll be covering these things individually in later videos as well. So if you like the video, please share and subscribe to the channel. And if you want anything else to be covered, like if you have any questions about Grasshopper tools, you can just leave a comment below. Thanks for watching.